Hello, welcome to section 2.5. What we're going to do is talk about absolute value equations and inequalities. So throughout this lesson, we're going to solve absolute value equations. We'll talk about what absolute value means, and then we'll move on to a couple of inequalities where we're graphing our solutions on a number line. Pretty much what we did in section 2.4, except a little bit different because of what absolute value means. So that's probably going to be the best starting point, is to talk about what absolute value means, which is essentially how far a number is away from zero. So I want you to imagine that you are standing on zero, and that's where your house is, that's where your street is, and if you leave your house and walk 5 miles away, where are you going to be? So if you left your house and you went 5 miles to the right, you would be at 5. Well, what if you went 5 miles to the left? Would you tell somebody that you drove -5 miles or you walked -5 miles? That wouldn't make sense. You've walked another 5 miles, but what that means is that this point here and this point here are both the same distance away from zero. Both of these numbers are 5 units away from zero. So what that means is when we have these absolute value equations and we're solving them, we're going to have two answers. So what you want to do, and the key to doing this, is to break up your answer or your equation into two separate equations. So let me explain what that means in words, because that was like a horrible sentence. I want to know in this first example, so I'll kind of just wipe out what I just did over here. In this first example, it says x minus 12 in the absolute value bars is equal to 5. So what it means is you're going to take some number and you're going to subtract 12, and when you take that distance, it is 5 units away from 0. So since there's always two numbers that are going to be 5 units away from 0, we need to break this up into two inequalities. I know that x minus 12 can either equal 5, but I also know that x minus 12 could also equal -5. I know that both the number 5 and the number -5 are the same distance away from 0. And that's what absolute value is. It's that distance from 0. So these are real easy to solve. I'm going to add 12 to both of them. Add 12 to both sides here. So I know that x equals 17. Or we're going to go over here. X is going to equal -5 plus 12, which is 7. So if I take 7 and substitute it in here, 7 minus 12 is -5. The absolute value, though, of -5 is +5. The same thing, if I take 17 and I put it in here and substitute it for x, 17 minus 12 is 5, and the absolute value of 5 is still 5. So that's why both of these answers to that equation are going to satisfy the absolute value part. So these are both of your answers. In the next one, we're going to do the same thing. Once you have this quantity on the left side in the absolute value bars, we're saying how many of our answers are 18 units away from 0. So I know that 2x minus 6 equals 18, and I also know that 2x minus 6 is going to equal -18. So those are going to yield both of our two answers here. I'm going to add 6 to both of these. So for this one, I get 2x equals 18 plus 6 is 24. If you divide both sides by 2, I get x is going to equal 12, and that's going to be one of our answers. And then my other answer, I'm going to add 6 over here. Be very, very, very careful on your signs. I get 2x equals -12. And when I divide both sides by 2 here, I have a negative divided by a positive, so that's going to be -6. So my answers are 12 and -6. Next one, this is saying I'm going to take the absolute value of a number and it's going to equal -9. Here's a problem. And maybe you've seen the movie Ferris Bueller's Day Off, maybe you have not. But in this movie, what two people are trying to do is set somebody's odometer on their car backwards. So that's the thing that adds up how many miles you've driven. So I want you to imagine if I was driving like to Green Bay, Wisconsin, and I'm going to a Packer game. I would be driving straight north for 2 hours and I would get there. Now, if I go to Chicago, that would be 2 miles south, but the thing is, both of those numbers are positive numbers. The distance cannot be negative. So in this example, it's saying you're taking 3 times a number, you're adding 1, and somehow when you take that distance away from 0, it's a negative distance. Well, that's impossible. You can't be a negative distance away from 0, so this means no solution. I'm not even going to attempt that problem because there's nothing that we can do. I know that no matter what x is, if x is a negative number here and I take my absolute value, it's going to turn it into a positive number because absolute value means distance. There's no way an absolute value is going to be a negative number. Alright, next example, just like the ones we did before, I'm going to break this apart. So now we're saying what numbers would be 14 units away. So 5x plus 1 equals 14. It's a really ugly plus sign. And then I also have 5x plus 1 equals negative 14. So you might be asking yourself, well, why am I doing the negative here if I couldn't solve this one? I want you to look at the difference between this problem where my cursor is and then this one down here. Notice how this had the absolute value bars right away from the beginning and had a negative number, whereas in this one, when we're breaking it apart into 2 separate equations, you're dropping the absolute value bars. The reason we are allowed to drop the bars is because we're saying how many numbers are 14 units away from 0. So let's solve this then. I'm going to subtract 1 here. 5x equals 14 minus 1, which is 13. And if you divide this out in your calculator, 13 divide both sides by 5, you're going to end up with 2.6. And then this problem over here, I'm going to subtract 1 on both sides. 5x equals negative 15. And when I divide both sides by 5 here, you're going to get a negative 15 divided by a positive 5, which is negative 3. So these are my 2 answers in this case. X is either 2.6, and that would work if you substituted it in and solved. That would be 14 units away. And if you substituted negative 3 in here, you would get a negative answer. But when you take the absolute value, you get a positive answer. And then these ones. Notice these are a little bit different because I have a little bit more going on each side of these equations on the left-hand side. So in this first example, what I'm going to have to do is add 7 first before I break up my absolute value. So now I'm going to bring this down. X plus 3 equals 47. And then I'm going to split this up into 2 equations. So now I'm going to say x plus 3 equals 47. And I'm going to say x plus 3 equals negative 47. So we'll solve both of these. I'm going to subtract 3 in each case. So x equals 47 minus 3 is 44. And over here I'm going to subtract 3 and end up with x equals, and that's negative 47 minus 3, negative 50. So just to check your answer if you wanted to, you could take both of those numbers and substitute them back in for x in your original equation. Next one, what I want to do first, because I have 2 times this whole quantity here, I don't want you to think about this like it's parentheses. I do not want people to distribute through these. Instead, let's get the 2 out of there. We know that 2 is being multiplied by this whole thing, so I can use the inverse to multiplication, which is to divide. Divide out first, the absolute value of x minus 6 is equal to 48 divided by 2, which is 24. And now that I have my absolute value by itself, I can break this up into 2 separate equations. X minus 6 equals 24, and x minus 6 equals negative 24. And what I'm going to do is add 6 to both sides. So I know that x is going to equal 30. And then my other answer, I'm still going to be adding 6 to this. Just be very careful with your signs. Negative 24 plus 6 is negative 18. With these ones, a couple more examples. This would just be showing you a couple more order of operations first. So with this one, to do the reverse order of operations, I'm going to need to subtract my 4 on both sides. 5 times the absolute value of x equals 75. And then what you're going to have to do is still divide this. So before we're even breaking this up into 2 separate inequalities, you need to divide both sides by 5. So I know that the absolute value of x equals 15. So what is x going to equal? Well, just split this up. X is going to equal 15, or x is going to equal negative 15. Next one, I'm going to do this the same way. reverse order of operations, I need to add the 6, or why am I adding 6? I need to add 5 first. So 2 times the absolute value of x equals 16. And then just like we did in the last problem, 2 is being multiplied by the absolute value of x, so I need to divide both sides by 2. So I know that the absolute value of x equals 16 divided by 2, which is 8. So again, which numbers are 8 units away from 0? That would be positive 8 and negative 8. So now that we have the absolute value equations done, we're going to move on to absolute value inequalities. And these ones are going to look a little bit different, not much different. You're still going to want to get the absolute value by itself first before you break these up. And you're still going to want to break it up into a positive and negative answer. The only difference, though, is now that we have an inequality, first thing is that we're not going to have the no solution type problems with the inequalities. But also, when we break this up into 2 separate, instead of equations, we're going to have 2 separate inequalities. You'll also be flipping the sign. So I'll show you what that's going to look like. First problem is going to be x minus 3 is less than or equal to 6. So notice I'm just dropping the bars. Your other inequality, x minus 3, you have to flip the inequality. So now it's going to say greater than or equal to, and you also have to change the sign. So from positive 6 to negative 6. But solving these is going to be the exact same thing. We're still going to solve them the same way just like you would an equation, and we're going to graph them just like we did in equalities on a number line. 6 plus 3 is 9, and I also have here, I'm going to be adding 3. X is greater than or equal to negative 3. So I have x is less than or equal to 9, so I'm going to find where that is on a number line. 9 is right here. You know what, I'm going to switch color. I'm going to put closed dot because it's less than or equal to, and that's going to be less than or equal to, so everything going to the left. And then on the other end of this, I know that x is greater than or equal to negative 3, so 1, 2, negative 3 is right here. That's also a closed dot, and since it's greater than, it's to the right. So what I'm going to do at the very end then, just to make this compound inequality correct, since x is both of these things, it's greater than or equal to negative 3, and it's also less than or equal to 9, you want to put the word and in the middle, which indicates that any of those solutions is between that. It is greater than one number and it's less than another. With this one, it looks pretty complex. There's a lot that's going on in this problem. So what we're going to have to do first, we'll take a deep breath, we're going to have to get the absolute value part by itself. So the first thing I'm going to have to do is add 8 to both sides. Now I have 2 times the absolute value of x minus 1 is less than or equal to 18. Next step. I don't like this 2 there. 2 is being multiplied by this absolute value quantity, so I need to divide both sides by 2 to get rid of it. Now I am left with the absolute value of x minus 1 is less than or equal to 9. So we're in good shape right now to break this up into 2 separate inequalities, which is what I'm going to do next. X minus 1 is less than or equal to 9, so I'm just dropping the bars. Your other one, x minus 1, flip the inequality to say greater than or equal to, and change the sign from positive 9 to negative 9. So take your time when you're working on those. Make sure you're changing the sign of the number, and you're also flipping the inequality. And then all we're doing is just solving these. In this case, we're adding 1 to both sides. So x is less than or equal to 10. Add 1 over here, and I have x is greater than or equal to negative 8. So this first one, x is less than or equal to 10. That's going to be a closed dot right over where 10 is because it's less than or equal to. I'm going to be going all the way to the left, and I'm going to find where this other side is. X is greater than or equal to negative 8. Negative 8 is right here, and that's going to the right then because it's greater than or equal to this. So since we have a solution set where we're on the inside of both these dots, I also want to go back and put and here because x is less than or equal to 10 and it's greater than or equal to negative 8. Last problem? Yep. Last problem then. I would definitely recommend pausing the video, try this problem yourself and see if you're correct. This is going to look just like the last example we did where we're going to have to get the absolute value part by itself first. In order to do that, let's subtract 5 first. I have 3 times the absolute value of x plus 2 is greater than or equal to 18. Now we can divide by 3. If you were to divide by 3 first and then subtract 5, it would not be pretty. And again, we do not want to distribute. So the way that I did it is the way that I want this problem to be solved, where you're doing the inverse order of operations. We're subtracting the 5. Now we're going to divide by 3. I get the absolute value of x plus 2 is greater than or equal to 18 divided by 3, which is 6. Now we can break this up into x plus 2 is greater than or equal to 6, and then x plus 2, flip the sign to less than or equal to, and change it from a positive 6 to a negative 6. Subtract 2 here, so I get x is greater than or equal to 6 minus 2 is 4. And then over here I'm going to subtract 2 on both sides, and I know that x is less than or equal to negative 6 minus 2 is negative 8. So on the number line, x is greater than or equal to 4, so I'm going to find where 4 is. I'm going to put a closed dot there because it's greater than or equal to, and then that one's going to the right. You are greater than or equal to 4. Less than or equal to negative 8. So negative 8 is going to be over here, closed dot again, but now it's less than or equal to. Notice our arrows are pointing in opposite directions. You cannot be both of these. You can either be greater than or equal to 4, or you can be less than or equal to negative 8. So go back and put an or in there. So to recap what we did, starting from the very beginning of this, a lot of stuff. We solved, when we first talked about what absolute value meant, we solved absolute value equations. So the first 4, we talked about the no solution case. We talked about what happens when you have other stuff next to your absolute value on the same side of the equal sign, and how you have to break up the 2 equations. And then we moved into inequalities, where we would break them up into 2 separate inequalities by changing the sign of the number and flipping the inequality, and then graphing our solution.